start again. Sine, cosine, and tangent are fractions. Mathematicians just decided to use some funky Greek names for those fractions. So sine is just some fraction. Cosine is a type of fraction. Tangent is a type of fraction. Sometimes the questions that are going to be given to you are as simple as what you see here. They're just going to ask for the sine, the cosine, and the tangent. In which case, all you have to write down is a fraction. But you should start by circling the angle that's involved. So if we're asked to do sine of angle A, go up to A. Circle it. We're supposed to use that as our frame of reference. That's where everything is directed towards. Do you guys remember SOHCAHTOA? SOHCAHTOA. That's a way to remember that sine is O over H. Cosine is A over H. And tangent is O over A. Well, that's great, unless you don't know what O and A and H mean. What does O mean? It means opposite. And what we mean by opposite is on the other side of the triangle. What's H? Hypotenuse. That's not going to change. That's always the hypotenuse. How about A? Adjacent. So we're talking about opposite or this is opposite, this is adjacent, which is close to. And what are we talking about? We're talking about in relation to the angle that we're talking about. So it's always opposite the angle or adjacent to the angle. Grab a calculator.
I actually have to go to take another test, so can you just take this one?
Yep. And look for this video in chapter 7.
Alright, thanks.
Yep. So since we're looking for sine, what fraction do we want? We want O over H. So start with that. O over H. What is opposite? Oops. What is opposite that angle? .108 is directly opposite or on the other side of the triangle from A. What is the hypotenuse of the whole situation? 180. That's not going to change. Can you guys reduce with your calculator? How do you reduce 108 over 180 with your calculator? Three over 5? All right, we'll put that right over here. 3 over 5. And you're done. All we wanted to know was the fraction that mathematicians call the sine fraction. If we want cosine of B, we have to center our focus on B. Now I'm looking at this angle. Everything is now in relation to that angle. What did we say the cosine fraction is?
A over H.
That's A over H. What does A mean? Adjacent. What is the closest side to angle B that is not the hypotenuse? Right here. It actually forms part of the angle. That's adjacent to B. And is the hypotenuse still the hypotenuse? So that's going to reduce to 3/5 again. We only have 3 sides in here, so sometimes some of the fractions look the same. What's a tangent fraction look like? O over A. What angle are we focused on? Still B. So we're still at B. What is the side that is totally opposite on the other side of the triangle from angle B? 144. And what is adjacent to B still? 108. What is 144 over 108 reduced to? 4 over 3. So this is just meant to show you that all these things are fractions. But what can you always convert fractions into? Decimals. When you use your calculator is going to show them as decimals. But they ultimately come from some sort of fraction. Jump down here. Thank you. Just put them on there. If you've set your calculator up correctly, go ahead and put in sine, hit the sine button, then hit 49. What do we get when we do that to 4 decimal places? Round 0.7547 or something close to that. That's actually coming from a fraction from a triangle. You're just not looking at the triangle and you're just not seeing it. Mathematicians figured out all the sines, cosines, and tangents that go with every single degree measure in a right triangle. When I was going to school, they were in the textbook. And if you look on page 920 in the textbook, there's a big table full of all of these decimals that are sine, cosine, and tangent. You don't have to do that anymore because they're all stored on the calculator. Just realize that this decimal is just like these fractions up here. It's just been converted into a decimal. Missing angle. Here, we had the angle and we wanted the sine. Here we have the sine or the cosine already, and we want to work backwards. How do you work backwards with sine, cosine, and tangent? You've got these little words right above sine, cosine, and tangent with the little -1, little -1, little -1. Little negative ones mean reverse operation. So you're going to do this. Cosine -1 by hitting the second function first. Hit the blue key, the second function, and then hit the cosine key. You should see that. Raise your hand if you don't know where that is or don't know how to get it. And we're going to put the 0.8582 in here. The result is going to be the angle. We're just inputting this, and we're going to get an output. How many degrees? So to the nearest degree, 31. You want to see problems where you're just finding the angle because you don't have to really do anything. You're just putting it in the calculator, it's giving you the answer. Is everybody clear on how to generate that? Second function, hit the key. The reason I'm using cosine is because that's what they told me to use here. All of this is really just so we can do the problems on the other side of this. Turn to the next page. This is really where it's useful, is looking at triangles. And you can't do Pythagorean theorem with this. Why not? Why can't I use Pythagorean theorem to find that? I only got one side. So you always try to do Pythagorean first. Then you start looking for numbers like 30 and 60, or 45 and 45. Is that what is there? No, we got 32. So the only way I can do this is sine, cosine, or tangent. First step. Always circle the angle or whatever's there. There might be a variable there. Circle it. That's where we're focusing our attention. Label 2 things. You label the side you have and the side you're looking for. I don't care about the other side. How many parts are there to a fraction? 2. If I have 3 things, that just confuses things. I need 2 things so I can make a fraction. What are you going to label 36 if it's all the way over there? Oh. What is x? H. What did mathematicians call the O over H fraction? So what is S? Sine. And I recommend you write it out this way. Write the formula without anything. Sine angle over 1 equal to O over H. Then we start filling in. What's the angle I circled? 32. Don't circle the right angle.
Attention building, attention all staff, and all students. Students, you must be with a teacher, coach, or sponsor at this time. If you are waiting for a ride, please wait in the front lobby, not in the cafeteria. Again, please, students, you must be with a student, you must be with a coach, or sponsor, or teacher at this time, okay?
What did we label as the O? 36. What did we label as the hypotenuse? X. What I recommend is that you let the calculator handle things. If I cross multiply this, and that's why I put a 1 underneath, to make it look like a proportion. What's 1 times 36? What's anything times x? If I had 5 there, what's 5 times x? So I just put that in front of the x. I can't really do anything with it. Your job is to get x all by itself. What if you had a number in front of the x? How would you get rid of it? Divide. So we're going to do the same thing with sine 32. You already know that sine 32 is some number that the calculator is going to get for you. It's some decimal. So whatever it is, I'm going to divide it. And I just got to make sure I do the same thing over here. This goes away. That was the whole point. Get rid of it from that side. Do that on your calculator. Do 36 divided by sine 32. Do that right now. Yep.
Could you have figured out sine 32 or doing all of that?
Yep. Either way. It's some decimal. We're just letting the calculator handle it. What is sine of 32? Just do that for me. What's the spelling?
Sine 32 is 0.78.
So the whole answer you should be getting, you said 67.9. And to the nearest 10. So that looks good. Instead of doing it that way, I could have done this. I could have said that sine of 32, what is that?
0.5299.
0.5299. So instead of dealing with the sine of 32 in here, I just changed that to this. But it's the same process. How am I going to get rid of 0.5299? I'm going to divide. So you can either let the calculator deal with it, or you can find it on the calculator and use that decimal to do the same thing, which is dividing by the actual number. And that's what you got to remember. This thing is not just 32. Some people get in trouble, they divide by 32. You got to divide by sine of 32, which is this decimal. And if you want to figure it out separately, you can. Either way, you're going to get 67.9. Does that make sense in the problem? Is the hypotenuse bigger than 36? Yes, we got 67.9. So at least it makes sense. Tell me what to do first for number 9. Circle the angle. That's our base of operations. What do I label? I label what I have, and I have to label what I'm looking for. How is that related to the angle? It's close to it. It's adjacent to it. I don't care about the other side. I'm not looking for it, and I don't have it. And I only need 2 things to make a fraction. I need to deal with A and H, which is called what? Cosine. So I'm going to do cosine angle equal to that. I like to put that over 1 and make it look like a proportion. What's my angle? 78. And I have an x over 34. Look at the difference in the 2 equations. Where's the x now? Where was the x before? Bottom. When the x is on the top, it's much easier because what's x times 1? X. Your x is already alone. Now you just have to do 34 times cosine 78. No division involved. I'm just cross multiplying this with this. Notice I put the 34 first. That saves on calculator errors. If you put it at the end, sometimes depending on the calculator you're using, it will screw it up. To the nearest tenth again, what do you get? I'm getting 7.1. If you're not getting 7.1, stop me, let's take a look, figure it out. That's why we're here, to figure things out. Was I looking for angles or sides for those first two questions? Sides. Both of those, I was looking for a side. I was looking for a side. Well, what am I looking for here? Angle. I still circle it. I'm looking for that angle. It's still my base of operations. I still label two sides. You might have more sides. If you have more sides, then you can choose any two that you want. Since I only have these two, I'm going to label the 86 as opposite. Or what am I labeling the 17 as? Adjacent. The legs are always either O or A. I'm not doing any of the work that I did over here to the left. This is just like problem 7. What did I do in problem 7? I did this inverse stuff. It's just input, output, anytime you are missing an angle. The only difference is we have the information in a drawing. So I need to know what function we're going to use, sine, cosine, or tangent inverse with this. Tangent, but it's tangent with a little -1. That's called inverse. And we're doing inverse because we were looking for an angle. Totally different set of circumstances. We're not setting up an equation really. We're just inputting to get an angle. Tangent, what's O? 86. A17. The only difference between this and problem number 7 is that we have a fraction instead of a decimal. But aren't they really the same thing? You can always convert between. That's why it looks a little bit different. Just put it in as is. How do you get to tangent -1? What keys do you have to hit? Second function, tangent this time. 86 divided by 17. Close, always get in the habit of closing your parentheses. And we want to the nearest degree. What's our angle? Which is 79 to the nearest degree. 79 degrees. Look at the difference between those three problems. One of them had a variable on the top. One of them had a variable on the bottom. One of them was just input and output. You didn't have to do any work. You just had to know how to use your calculator. Go ahead, you do the next two. Set up something and decide, am I looking at a side or am I looking at an angle? If it's an angle, it's a lot less work. Take a look at the front board. Did you label it the same way I labeled it? Did you have an A? Did you have an H? If you did, that's a good first step.
If you got A and H, then you should be writing something like this to start with, cosine. I would also write down what you're looking for. I'm looking for a side.
Did you guys get 36.8 for the first one? Make sure that you're getting X alone somehow. How you get X alone is up to you. If you're getting the same answer as me, you're doing it correctly. I'm just showing cross multiplication with a proportion. Did you circle X degrees? Did you label opposite and hypotenuse? O and H. What's the O and H fraction called? Sine of angle equals O over H. Do I want to use that? No. You use sine inverse. The O and the H go inside the parentheses on that side of the equation. The output is the angle this
Then
time.
DE, please come to the front office.
So totally different setup than that. What happens is people do so many of the one on the left that they end up starting to do it like I did for this one. Sine inverse. We have O, we have H, so 14 over 81. What's your output? 10 degrees? If you round it? What did you get, 9? Okay. Yeah, typically degrees, you're going to see whole numbers. Not always, just pay attention to directions. If you had another side, suppose you knew this side right here, and you knew all 3 lengths. You could choose anything that you wanted to choose. You just would have to choose 2 at a time. And it would be up to you. Here, we were limited. We only had 14 and 81. But couldn't you have done Pythagorean theorem? Couldn't you do Pythagorean theorem with 14 and 81 to figure out this length? That's more steps. But you always have the option of figuring out the other side. Other than that, just realize what happened here. We were looking for an angle as opposed to looking for a side. And if you look back at the original problems we did with this original triangle, were we looking for any sides? No, we had all the sides. All we were doing was making fractions. If all you're being asked for is the sine, the cosine, or the tangent, you're either using your calculator to find a decimal, or you're looking at a triangle to figure out fractions. Some people confuse these problems with problems like number 7. What was number 7 looking for? An angle. This is not asking for angle A, it's asking for the sine of angle A, which is a fraction. That's where I'm seeing people make mistakes. Read the directions, answer what's being asked for. If you're looking online,